This is a drawing showing the construction schematics of the Ragged Chute air plant built on the Montreal River around 1910 to supply compressed air to the numerous mines at Cobalt. At the Ragged Chutes air plant, the water flows into a large chamber 40 by 50 feet, where twin heads 16 feet in diameter with 72 14-inch diameter circular pipes in each head. The water covers these pipes at a controlled depth so that the swirling waters entering the pipes suck down large amounts of air and takes it to the bottom of the shaft 351 feet from surface. At the bottom of the shaft, the water strikes two steel-covered pillars, concrete-covered pillars, and then proceeds 1,221 feet in the horizontal tunnel, and then discharged through the exit shaft into the Montreal River. These steel-covered cones at the bottom of the shaft help to separate the air from the water, and as the water and air travel along this tunnel, it rises and comes into an air chamber or a receiver, and then rises to the top, and it will reach a pressure of 125 pounds per square inch. This air is sent to surface through a 24-inch steel pipe, and from there it is sent on into the Doomer's mines in Cobalt. If the pressure rises above 125 pounds, or a little bit more, it forces this water to drop a certain amount, and then that action causes excess air and water to travel up this discharge pipe and exit into the atmosphere, which makes the blow-off that you'll see later on in the film. This blow-off would happen at anywhere between 125 128 psi. Before the plant was shut down, there was numerous experiments carried out, and it was found that having 3-inch pipe, plastic pipe, inserted in these pipe and sticking up roughly 8 to 10 feet in the air and down a certain amount into the pipes below, it increased the efficiency somewhat. I'm not just sure exactly how much better it was, but the engineers told me it was a bit better. This plant quit making air for the mines in somewhere around 1975-76, and then it was experimented with over a few years, and these pictures were taken in 1986 on the last day that the plant was in operation after the experiment.
This is the Ragged Chutes air plant, May the 26th, 1988. The plant is out of operation. I'll go down here to see if they're going to start it up temporarily. Lots of noise in the background. The water above the falls goes down the shaft roughly 300 feet, travels 1,200 feet to a discharge shaft, and comes up and goes back into the river. And in the process it traps air. Fountain falls below us, upper notch, lower notch, and into Lake Temiskaming. This is the Montreal River.
The project engineer is pointing out that using plastic pipes inserted in the steel intake pipes made more air than using the former method. This is the last of the experiment before decommissioning the air plant.
got a good picture of Frank there. He's got that hood over his head. This is probably the last shot we'll get of Ragged Chutes air plant, eh? What's this, June the 2nd today? Yeah, June the 2nd, 88. Oh yeah, yeah. Yeah, it's just starting there now. This is the Ragged Chutes air plant. This is the last day that this plant will be in operation this year. Last test run before it's taken out of existence for good. This is the blow off after the air plant builds up pressure and it gets over its pressure. It's relieved by blowing air and water into the atmosphere. Pressure will drop low and then it'll build up and shoot 150 feet or so into the air. We're standing on a rock outcropping just below the falls. You can hear the roar of the rapids in the background, and we're looking down the river about 1,000 feet to where the blow-off is occurring. I'll back this up and get a little wider angle shot. Zoom in on this with the telephoto lens. On a bright sunny day, water and air is all mixed up with sunlight and there's rainbows all through it. And if you talk into it, like there's quite a bit of noise here. What?
I can't talk anymore.
Be loud because the noise will drown you out.
Well, I won't talk.
Well, go ahead and talk. It could be something.
Oh, I see.
Just wanted to get my face on the camera against the backdrop of that blow-off. This is going roughly 200 feet in the air. The water's being blown off by 122 pounds of air pressure. Yeah, there's Bud trying to keep the black flies away.
They ate the first bunch of leaves I had.
From a little different angle here, showing the full width of the river and hills in the background. And the blow off from this area. Of the blow off downriver about 800 to 1,000 feet from where we're standing. We're going to shut the camera off now and go down a little closer to it. When we get down close, there'll be so much noise you won't be able to hear anything that the person is saying. We've moved up fairly close to the blow-off, somewhere within about 100 yards or less. The sun is shining, but we don't seem to be able to get any rainbow effect. There's a rule, if you get the right angle and the sun shining through, you can get rainbows. 100 feet now of the valve house. This is the air line where the air comes out after being made in the underground chamber, and this is the start of its trip to the numerous mines that used to use it in the cobalt area. If we turn slowly to our right, we'll pick up the spot where the excess pressure and water is being ejected from underground. And we'll try, I've got the camera on wide angles, we'll try and get a picture of it coming out and as it goes up into the air. Get a little bit closer, and you can hear the roar of the water makes as it comes out from the underground. You can see the water boiling as it makes its way into the river, and this is the excess pressure being blown off into the atmosphere. We're within about 50 feet of it at this point. From this point, there's just a vague trace of a rainbow up near the top of the arc. The sun's not hitting it at quite the right angle. I'm not going to say too much. Yeah, get on your knees.
Doug's a little taller, so I have to stand on my toes here. So balance that off here. We need Well, say something, Bill.
Yeah, you can't hear anything here.
Well, I'll take a shot right to the top, Bill.
Yeah.
All right.